Good morning everybody, myself Acharya Vishvendra and today I am going to discuss a worksheet on fluid container. So let's begin. So here is the worksheet. We are being given a fluid container in which a fluid is filled up to height h. Area of cross section is capital A and we make a small hole of area small a at a point which is vertically at a distance of small h from the top surface, and suppose liquid comes out with a speed v. So the first question is volume of the liquid. So volume of the liquid here is AH. So volume of the liquid here is AH. Then we have mass of liquid. So mass is density into volume. So it will be DAH. Then weight of liquid, weight is mass into acceleration due to gravity. So that will be DAGH. Then speed is equals to root 2GH. Then we have volume outflow rate, which is area into speed. So that will be A root 2GH. Next we have the thrust force on the container. So the thrust force is dAV square. Substituting V square as 2GH, we have thrust force as 2AGH. Then acceleration of the container. So force is equal to mass into acceleration. That gives MA dash is 2AGH, from where we can calculate A dash as 2AGH by M. Now there is a question on time taken to decrease level of liquid from H1 to H2. So the time is capital A by small a root over 2 by g into root h1 minus root h2. Now in the next question we make the hole at the bottom of the container. So speed will be root 2gh. Now if we draw the graph between v and h, that will be a parabola turning toward h-axis. However, if we draw graph between v and root h, that will be a straight line. Now let's calculate the time taken to decrease height of liquid from h to h by 2. So substitute h1 is equal to h and h2 is equal to h by 2. We have t1 is equal to a by a root 2h by g 1 minus 1 by root 2. Then we have time taken to decrease height from h by 2 to 0. So take h1 as h by 2 and h2 is equal to 0. We have t2 as a by a root 2h by g into 1 by root 2. Then if we calculate ratio of t1 by t2, it comes out to be root 2 minus 1. After simplification, it comes out to be 0.414. So it's clear that it takes less time for the upper half of liquid to get emptied than the lower part, the lower portion. That is quite obvious because speed will be higher for the first case, so time will be lesser. However, if we calculate T2 by T1, it comes out to be 2.415. So we can say that for decreasing the upper half level of the liquid, the time taken is about 41.4% of that taken to decrease the lower half. And if you inverse the ratio, it comes out to be 2.415. So now suppose this is the question that this is h by 2, this is h by 2, this is v. So t1 by t, if the t is the total time. So from here you can see that this is capital T. So t1 upon capital T will be 1 minus 1 by root 2. After solving this, it comes out to be 0.292. And if we inverse the ratio, it comes out to be 3.42. If you find t2 by t, it is 1 by root 2. You can see over here that this is capital T, this thing. So t2 by t will be 1 by root 2, which is about 0.7. And t by t2 is root 2, which is 1.414. If we add t1 plus t2, it is equal to capital T. And if we find t1 plus t2 by capital T, it is equal to 1. So in this way, there are certain problems based on this and we can solve it out. So these are the basic worksheets to make sure that you can optimize your time and energy. Thank you and have a nice day.